Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about circular linked list. So there are some operations in circular linked list. See here, the first operation is node creation. How to create a node in a circular linked list. Okay, before that, we can see about the structure of the circular linked list. See here, this is structure of the circular linked list. First, it is 20, then 30, then 31, then 19. So this 20 is pointed by what? By head. Okay, so by this we can say that 20 is the first node, then 30, then 31, then 19. Okay, this is the basic structure of circular linked list. The last nodes next will be what? Head. So prerequisite for this circular linked list is you must know about the oops concept, and watch out my introduction video in linked list. These both are in the description, just watch it. Now get back to the concept. Okay, to create this node, we want two things. What are the two things? We want the data to be inserted, and also we want the next address. Okay, so these are the two things we want to create this individual nodes. I can say this node is like value in it and next address in it. Can you understand now? So to create this, we want to use a user-defined data type. What's the user-defined data type? It is class. We can use class. But how we are going to use this? Like, see here, class. Let me take another color. Class node. Inside this, def init of self, comma, value, comma, sorry, instead of value we can take data is equal to -1, and next address is equal to none. Fine. So this is our constructor inside which we are going to initialize these two values. Okay, self dot val. So for this val, what is my initialization? It is data. And for this next, we are going to initialize the next address. So self dot next is equal to next address. That's it. So this is the code to create this individual node only. This individual node only, not an entire linked list. Now we are going to construct a linked list, that is a circular linked list from an array. Now we are going to construct. Fine. So see this. So this is the input, and this should be our output. Can you understand this? We want to create a circular linked list whose head is what? 10. Fine. Now, how to do this? See here. Initially, we want to check whether the array has some values. So, if len of this array, input array, is greater than 0, which means it has some values. If it has some values, what is our first step we have to do? Just take the first node and take the first element and create the node. Okay, the first element is ARR of 0, right? So I want to create a object for that, which means the node. Yes, I already told you this is a structure. So this is a structure, right? To create a node, we just create an object. Obj is equal to just node of some data and values inside this. You may give. Okay, now see here, temp is equal to node of ARR of 0. That's it. Can you understand now? We are just passing the data. Now we successfully created what? 10. And next is none. That's it. Now we want to point this at what? Head. So this is our first node, right? So it is pointing as what? Head. Now the second step is for I in range of 1 comma len of ARR. I'm just going to traverse 8, 7, 20 and creating a node, and continuously I'm just placing it to the next node. Okay. Now in this step, what should I do? First, I want to create a node. Okay. Temp is equal to node of ARR of I. Okay. I just created a node. So now I have created what? What node? It is 8. 8 none. This is the ith value, current ith value, right? Now I want to say this is 200 address. Then I want to change this as 200, right? This none as 200. So how can I change it? Just put head dot next is equal to what? Temp. That's it. So I successfully combine these two. And then again move on and create what? 7. 7 none. Again, just take for example, this is 300. Then I should take this none and take and modify as 300. But what we have done here, head dot next is equal to 10, which means this 200 is again changed to what? 300. There is no purpose, right? We are just doing a next operation for the heads next. So we want to do here, right? Whether we can change this head here? No, don't ever do that mistake. Just keep a track like another variable. Okay, instead of this head, use that another variable and current is equal to current dot next. Can you understand now? Yes. Just see here. First of all, current is here. Okay. Now we have successfully created 8. Now this 200 is gonna modify this none. Again, current comes here. Right? Now this 7 is created. Now this none is modified as 300. Now again current goes here. Now new node is created. What is a node? It is 20. Okay, and the address is none. Fine. Now this none should be what? Updated as 400, right? 400, because see here current dot next is equal to temp. So it is updated as 400. That's it. So it finishes at this point. Now at last I have to modify this none as what? 100. Let me take this address as 100. Then I want to change this address as 100 so that it again connected here. Can I understand this? Right? So at last we want to put what? Current dot next is equal to head. That's it. So this is my entire code to convert an array into a circular linked list. Fine. Now we are going to see about what? Printing the linked list. Okay. Let us take this linked list as an example. Now see carefully. We are just standing here at this 10, right? Now we want to print 10, 8, 7 and 20. So initially take the current as head, and while current, what should I do here such that it stops up to here? It should stop up to here, right? Up to here. So what should I do? Okay, if I think I was like, if current's next is head, then I should stop. Then this 20 will not be executed. So that instead of taking this, just write true. First make the loop as infinity. Then we can give some conditions and break it out. Okay. First of all, print what? Current dot value. So current dot value is printed. Now this 10 is printed, and I should make sure that go to the next node. Current is equal to current dot next. Go to the next node, and if that next node is head, then break it. Can you understand? First I just executed, then only I am breaking it. Fine. Now let us rerun it. See here. First its current is finding here at 10. Okay. What is my output now? Output is initially printing the 10. Okay, 10. Now current is equal to current dot next. Now it is at 8. Whether 8 is head? No. Head is what? 10. Okay. 8 is printed. Now again. Yes, again current dot next. It is 7. 7 is printed. Again it is 20. So 20 is printed. Again it is where? It is at 10 now. Here it comes 10. Whether 10 is head. Yes, these two nodes are same, so break it out. So this break will be executed, so it this terminates. So this is my output. Can you understand? Okay, here we can face a edge case here. So before writing this code, here we want to insert something. What we have to insert? If we don't even have head, we not have head, then what should we do? Just print empty. Okay, and then return just head, that is none. Can you understand it? So it is the way to print a circular linked list. Now let us see about the insertion first. So insertion of a circular linked list. So in insertion we have two types, right? What are they? First one is start. So let us see start. So to insert a start, if I give, for example, insert value is equal to something like 90, then this 90 should be inserted here. Should be inserted here, like see here, 90, then 10, then 8, then 7, then 20, and this should be my head. Okay, so it is quite easy. I will tell you how to do this. See here, if I want to insert here, if you already watched my singly linked list and doubly linked list video, what we will do, I will put 90 here, and I will take this link and connect here, and take this link and connect here. This is what we have to do, right? So I want to stand at here, at this position. So just go on up to this position. So just take current is equal to head, and while current dot next is not equal to head. Can you understand why I am putting current dot next is not equal to head? Because here, this is our point. At this point, it is pointing to what? Head. So it is a last node. So I have to go up to this. Can you understand this? Right? Okay. Come up with me. It is easy. Now current is equal to current dot next. Up to this, we are just traversing and go. And now my current will be pointing here. Now this is the point to create the node. So temp is equal to node of 90. So I have created successfully. Now this current next should be what? Temp. And this temp next should be what? Head. Can you understand this? I just making this current to point to this temp and temp to point to this head, so that I can get this as our output. Can you understand this? Now there is only one step remaining. What is that step? Head is pointing to here head is pointing to where? Head is pointing to 10. But where should I my head points to? At 90, right? So my remaining one step is just take head is equal to temp. That's it. So this is our insertion. This is our insertion, and there is a one edge case. What is that edge case? I want to check here that if not head, if there is not head, then what should I do? Should do like, if there is no head, head is equal to node of 90, right? And after this, head dot next is equal to head. Why I am putting like this? Because it is a circular linked list, right? If there is only one element left, it points towards itself. Can you understand this? Right? Okay. Now, the next thing is, see here, we want to do for end. Want to do for end. Okay. Let me paste it. Right. Now, observe this. What we are going to do. See here. Here, I have to insert 90 here, right? But head should be pointing here. So I can say, if I remove this line, it is the answer for this question. Can you understand it? If I remove this head is equal to temp line, this head is equal to temp line, I can insert this at last. That's it. So can you understand now what we have done, right? So this is the inserted the end code. See here, these all are same as start and end. But in start we use get is equal to temp, but in end we use what? Just keep it. Just keep it. Don't do anything. Okay. So try this by yourself. If you don't got the answer, just comment below so that I can post a new video. Okay. Now we are going to see about the deletion. Deletion at start and end. Okay. Here deletion at the start. So in deletion at start, we want to delete this head node, right? This head node. So to delete this head node, where should I stop such that I can delete this node? I should stop here at this 20 so that I can connect this 20 and this 8 such that it is deleted. Right? So go to this 20. How to go to this 20? We have already seen, right? Current is equal to head. While current dot next is not equal to head. After this, move on, move on, move on, and reaches the end of the circular linked list node. Right? Now, what should I do? I should take this 20 and connect to where? At this 8. So current dot next, yes, equal to current dot next. Fine. Now a link is created between them. But I have to delete this head, right? So delete head and re-update the head as what? It is what? Current dot next. Now 8 is the head. Okay. Now this 8 is the head. So this is our output. Fine. Whether there is some edge cases like see here, if there is only one node, only one node. So this is our starting node and so the ending node, right? So we want to delete this. So we want to check whether first thing if head, if there exists head, sorry, if not head, if there exists no head or not head dot next, it's our single linked list. We have studied in single linked list, right? Like the next address is null, but here we use what? Head dot next is not equal to equal to head, which means this node is pointing towards itself. At this moment, what should I do? I should return what? None. That's it. In this case, in not head, it denotes that there is no node. So obviously deletion has no impact, right? And if there is only one node, I have to delete that node. That's it. Can you understand the deletion at start? Now it's time to see the deletion at end. So let me paste it. Now deletion at the end. In deletion at the end, we want to delete what? We want to delete this 20. To delete this 20, I have to connect this 7 with head, right? So first I have to stop at this 7. Now how can I stop at this 7? Fine. So I have to stop at a point where its next is head. So current is equal to head. While current dot next is not equal to head. At this moment, I have to traverse one by one. Yes, and then I have to do what? Current dot next equal to head. But before that, we have to delete it, right? So temp is equal to current dot next, and then after connecting these two, I have to delete what? I have to delete temp to free this memory space. Can you understand it? Right? temp is equal to current dot next, which means I just storing this 20 in my temp, and then current dot next is equal to head, pointing this current towards this head, and then I am just deleting this temp. Can you understand? Now my result is what? 10, 8, 7. Okay, whether there is some edge cases. Well, let us think about it. If there is no node and there is only one node, like 10 pointing to itself. Okay, at this moment, what should I do? And also 7, 10, and this 10 points towards this 7, where it is head, and we want to delete this element, right? We want to delete this 7. Fine. Let us think about it. First step is, if not head or head dot next is equal to head, then what should I do? Just return none. Same as the previous case, that deletion start, right? Now this is the case. Now see here, initially I'm at head, right? Initially I'm at head. Now it's next is head. Yes, it is head, right? So I want to stop here. So current is initially here. Current is here. Now see here, I just replace this what? It is next. See here, temp is equal to current dot next. So this is our temp. Now current dot next is equal to head. So current is this. So 10 is connected towards itself, and then delete temp. Now temp is deleted. So it is not our edge case. It is not our edge case. Can you understand? So our edge case is like if it is pointing towards itself, or it is none. It is none. So these are the two edge cases we have. So that's all about the circular linked list. In next videos, we are going to implement the circular linked list code, and in this playlist, we are going to see about more and more problems about linked list. Thank you.